Assume that the sales of a certain appliance dealer are approximated by a linear function. Suppose that the sales were... Okay, so let's, before I move any further, when they say approximated by a linear function, what's the first thing that should pop in your head?
A graph.
Well, yeah, but a graph of y equals mx plus b. That's what a linear function is. So sales were 7,500 in 1982 and 71,500 in 1987. Well, that's a significant increase. Let x represent 0 at 1982. Okay, so here's what we have. We have x and f of x. And we basically got to write an equation of the line. So let's just find the equation given the yearly sales. So when x equals 0, which is 1982, it had 7,500 in sales. 5 years later, in 1987, well, wait, let's check that out. If 0 is 1982, then 1 is 1983, 2 is 1984, 3 is 1985, 4 is 1986, and 5 is 1987. So yeah, that's right. It was 71.5. All right, so the first thing I need is the slope, and that's y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. I'll do the bottom. It's 5 minus 0. What do you guys think the top should be?
7.
So we'll do that on our handy-dandy calculator. I've got 71,500 minus 7,500. So that's 64,000 divided by 5, right? So we got, I guess that seems right, 12,800. So that's the slope of the line. Boy, it's a pretty high number, but that's what it is. So I did all the math, and this has a slope of 12,800. So now I know what m is. The only thing I really need to know is the y-intercept, which is b. Now that occurs when x equals 0. I could solve algebraically, but guess what? We know what the y value is when x equals 0, don't we? So this thing is y is equal to 12,800 times x plus 7,500, or C.